Highway light systems, especially those designed for energy saving, can present unique challenges when troubleshooting. Firstly, let's discuss the common issues of burned fuses and intermittent operation. A primary cause could be voltage fluctuations. It's crucial to check the voltage supplied to the system. If the voltage is dropping below 20% or exceeding 277 volts, this could cause fuses to blow or lights to fail intermittently. Ensure the system's voltage regulation is functioning as intended. Secondly, inspect the resistors within the system. If you find a blown or damaged 20 amp fuse in the resistors, replace it immediately. Thirdly, verify the integrity of the wiring. Ensure that all wiring connections are secure and not loose. Loose connections can cause arcing, leading to fuse failures and intermittent operation. Damaged switches can also contribute to the problem. Test the switches that control the system to ensure they are working properly. Use a multimeter to check for continuity and proper voltage flow. Now let's address the issue of lights not turning on. The first step is a simple bulb check. Replace the bulb in the affected light. Even if the bulb appears to be intact, it may have an internal fault. Next, test the ballast. Disconnect the ballast and test it with a voltmeter to ensure it is providing the correct voltage to the lamp. A faulty ballast can prevent the light from igniting. Inspect the starter. Replace the starter if it is damaged or not functioning correctly. The starter is responsible for initiating the arc within the HBS lamp. Another potential cause could be a control gear issue. Check the dimming controller or other control gear associated with the system for any faults. These components may malfunction and disrupt the lighting sequence. Environmental factors can also play a role. Cold or wet conditions can affect the operation of electrical equipment. Consider checking the system during various weather conditions to identify any environmentally related issues. Additionally, verify the power factor. Ensure that the system has a power factor of 0.9 or higher to improve energy efficiency and reduce voltage fluctuations. A low power factor can cause increased current draw and voltage drops. Load balance is another critical aspect. Verify that the load is evenly distributed across all the lights to prevent overloading or voltage imbalances. Uneven loading can stress the system and cause failures. Remember that the system employs a step-down process where after the lights turn on at their brightest with special bulbs, the power gets stepped down 20% to save energy. When the voltage goes below 20%, the system steps up the volts to 277 volts again. This process repeats until the lights turn off at daylight. Understanding this cycle is crucial for effective troubleshooting. For example, if the voltage regulation is failing, the system may not accurately step down or step up the voltages required, which can cause stress on the components and lead to failures. In such a scenario, consider utilizing a power quality analyzer to monitor voltage fluctuations and harmonic distortion. A power quality analyzer can provide detailed insights into the electrical characteristics of the system, helping pinpoint the root cause of the problem. Be sure to check the condition of the capacitors used in the system. Capacitors are often used to improve the power factor and reduce voltage fluctuations. If the capacitors are failing, they can cause voltage instability and lead to premature failure of other components. Check the physical condition of the capacitors. Look for any signs of bulging, leaking, or corrosion. Use a capacitance meter to verify that the capacitance value is within the specified range. Also check the equivalent series resistance, or ESR, of the capacitors. A high ESR can indicate that the capacitor is deteriorating. Check the surge protection devices installed in the system. Surge protection devices, or SPDs, are designed to protect the electrical equipment from voltage spikes caused by lightning or other transient events. If an SPD has been damaged by a surge, it may no longer provide adequate protection. Inspect the SPD for any signs of damage such as discoloration, cracking, or blown fuses. Use a surge tester to verify that the SPD are functioning correctly. Examine the grounding system for the highway lights. A proper grounding system is essential for safety and proper operation of electrical equipment. Ensure that all grounding connections are secure and not corroded. Use a ground resistance tester to verify that the ground resistance is within acceptable limits. If the ground resistance is too high, it can indicate a problem with the grounding system. Inspect the lighting fixtures for any signs of water damage. Water can cause corrosion and short circuits, which can lead to premature failure of the lighting fixtures and other electrical equipment. Look for any signs of water intrusion, such as rust, water stains, or condensation. Ensure that the lighting fixtures are properly sealed to prevent water from entering. Check the ventilation of the electrical enclosures. Electrical enclosures need to be properly ventilated to prevent overheating. Overheating can shorten the life of electrical components and lead to premature failure. Ensure that the ventilation openings in the electrical enclosures are not blocked by debris or other obstructions. Use a thermometer to monitor the temperature inside the electrical enclosures. Make sure that the temperature is within the specified limits. Check the condition of the wiring insulation. Damaged or deteriorated wiring insulation can create a safety hazard and lead to electrical failures. Look for any signs of cracking, fraying, or discoloration of the wiring insulation. Use an insulation resistance tester, also known as a megometer, to verify that the insulation resistance is within acceptable limits. If the insulation resistance is too low, it can indicate a problem with the wiring insulation. Examine the condition of the electrical conduit. Electrical conduit is used to protect the wiring from physical damage. Ensure that the electrical conduit is in good condition and is not damaged or corroded. If the electrical conduit is damaged, it may need to be repaired or replaced. Check the tightness of all electrical connections. Loose electrical connections can cause overheating and lead to electrical failures. Use a torque wrench to ensure that all electrical connections are tightened to the specified torque. We torque the connections periodically to prevent them from loosening over time. If the system is equipped with a remote monitoring system, check the system logs for any error messages or alarms. Error messages and alarms can provide valuable information about the cause of the problem. Use the remote monitoring system to monitor the voltage, current, and power consumption of the lights. Monitoring these parameters can help identify any abnormalities in the system. Inspect the photocell. A photocell is a light sensor that is used to detect ambient light levels. The photocell automatically turns the lights on and off depending on the light levels. If the photocell is defective, it may cause the lights to turn on and off at the wrong times. Check the photocell to ensure that it is clean and free from obstructions. Use a multimeter to test the output of the photocell. Verify that the output voltage changes appropriately as the light levels change. Inspect the timers. If the system uses timers to control the lights, check to make sure that the timers are functioning properly. The timers should be set to the correct time and should be switching the lights on and off at the scheduled times. Use a multimeter to test the output of the timers. Verify that the output voltage changes appropriately at the scheduled times. Check the operation of the contactors. Contactors are electromechanical switches that are used to switch the lights on and off. The contactors should be closing and opening smoothly and without any arcing or sparking. Inspect the contactors for any signs of wear or damage. Use a multimeter to test the contacts of the contactors. Verify that the contacts are making good electrical connection when the contactor is closed. Ensure that the correct type of fuse is being used. Using the wrong type of fuse can cause problems with the electrical system. The fuse should have the correct voltage and current rating and should be of the correct type. Refer to the equipment manufacturer specifications for the correct type of fuse. Use a multimeter to test the fuse. Verify that the fuse is not blown and that it is conducting electricity properly. Consider using slow blow fuses. Slow blow fuses are designed to withstand temporary overloads without blowing. This can help to prevent nuisance tripping of the fuses. Check for any signs of corrosion on the electrical components. Corrosion can cause electrical resistance and can lead to premature failure of the components. Clean any corrosion from the electrical components using a wire brush or other suitable cleaning tool. Apply a corrosion inhibitor to the electrical components to help prevent future corrosion. Verify that the system is properly labeled. All electrical components should be properly labeled with their voltage, current, and power ratings. This will help to ensure that the system is operated safely and efficiently. Update the labels as necessary to reflect any changes to the system. Keep a detailed record of all maintenance and repairs performed on the system. This will help to track any problems that may occur and will make it easier to troubleshoot future problems. The record should include the date of the maintenance or repair, a description of the work performed, and the name of the person who performed the work. Regularly inspect the system for any signs of damage or wear. This will help to identify any problems early on before they become more serious. The inspection should include a visual inspection of all electrical components, as well as a functional test of the system. Follow all safety procedures when working on the electrical system. Always disconnect the power before working on any electrical components. Wear appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working on electrical systems, hire a qualified electrician to perform the work. By following these tips, you can help to troubleshoot and maintain your highway lighting system and keep it operating safely and efficiently. These steps will help to pinpoint the source of the lighting issues and ensure the highway lighting system operates safely and efficiently.